Hello, guys. Welcome to the stream. We're going to be solving a couple of lead code problems today, just like we did yesterday. And then maybe I'll probably set up another stream for Dota 2. Last time around, in the previous stream, we solved a medium and a hard problem, but what I felt was lacking is the lack of use of data structures to solve those problems. They were interesting problems, required a lot of thinking. Not a lot, but required some thinking. They weren't trivial, but didn't require deep data structures and algorithms knowledge. So I'm just going to try to pick something which is more along those lines, where I end up learning something new about a data structure or an algorithm. What about this container with most water? Merge K sorted lists. That seems easy though. Sudoku solver. That is a backtracking problem. First missing positive. Wildcard matching. N queens is a standard problem. Valid number, text justification. This is again, I think, a standard problem, something which I've already attempted. But let's do that. Let's do that because I know that this is a really popular problem which sets up an understanding and it sets up knowledge on how to apply one particular algorithm, I guess. But I don't really remember how this is solved. Although I think I've solved this at some point in my life. So let's just do this. It will be a quick revision problem. What do we have? We have two strings, S and T. With their respective lengths, and we need to return the minimum substring of S such that every character in T is included in the window. If there is no such substring, return the empty string. I need to find the smallest substring within S such that all the characters of T are present in whatever order in that substring. So B, A, and C contains all of the characters from A to C, so that's why it is the smallest substring and is a valid output. Okay, I think this is a classic two-pointer problem. You gotta have 2 pointers. I'm just gonna do a dry run on example 1. We have A, D, O. Okay, Adobe Code Bank. I'm gonna have 1 pointer here and another at the same position to begin with. uh, I need to have A, B, and C, and the need for A has been satisfied at the very beginning. So I'm just going to move R until all of the requirements have been satisfied, and that would be all the way till this C. Okay, at this point, what I'm gonna do is I'm gonna check how many of the characters I require do I have, and if there are any extras. So at this point there are no extras because A, B, and C each appear just once, which means that I cannot shrink this any further. Like, what I'm meaning to say is that this substring is an answer. Yeah, it is an answer, a valid answer, but it is not the most optimal answer, and there is no way to further find a substring within this, which is also an answer and is, smaller because it exists within the substring, because there are no duplicates. I hope that makes sense. Does that make sense? Yeah, I think it does. To rephrase, when I end up with such a substring where all of the characters which I need are there, but there are no extras, then that is something which is not further minimizable anymore, and it is an answer. It might be optimal, it might not, but it is like not reducible anymore. So at which point I'm just gonna like reset and just move on to the next part of the string, and I'm going to reset my pointers once more, so L and R now point to O, and repeat the same thing I did for this substring. Also, one more point which I forgot to mention is that let's go back to the point where my L and R were here and here. So I know that I have no extra A, B's, and C's to expend. So nevertheless, even though I don't have any A, B, and C left to expend, I'll try to move left to the right. But if the character at left is something which I need and I have no extras, then I gotta stop there. And we go back to saying that this is an answer which is not reducible any further. So let's do the same for the second half of the string, and it's going to end up looking something like this. Again, I have just one instance of A, B, and C, but over here I can move my left pointer towards the right a couple of times because I'm pointing to O, D, and E here, which are characters not needed. So I can just continue shrinking left till it reaches this, and I don't have any B left to spend, so I just gotta stop here and note this down as an answer. Then at the end, I'm just gonna check which substring had the smallest length, and that is gonna be my answer. So it's every character of T including duplicates, which shouldn't be a problem. Duplicates should not be a problem. Cool, I think, is this really that easy? Just gonna get to implementing this. Could you find an algorithm that runs in O m plus n time? I think my solution is it's exactly O m plus n time. Yes. I'll create a hash map unordered set int x, no, count for int I is equal to, or I think it should rather be, wait, what should it be? I'm gonna store the requirements in one data structure. This could be an unordered map, it could be just a vector of pairs maybe. Then I need to have an occurrence, or I need to have, yeah, well, okay, so I'll just have this, and for each iteration I'm just gonna copy this over into another deep copy. So let's call this r star. Each time I iterate over a character in the string, so C, I'm just going to check if RC exists, and if yes, then I'm going to decrement it. If not, I'm just going to ignore it and move on. At the end, I'm just going to run this loop till R star becomes empty, at which point I know that all of the requirements have been satisfied. And then maybe I'll also maintain an extras array maybe. So if I encounter an extra C, I'm just gonna make an entry 1. And then I'm gonna move the left pointer with a similar logic to what I did with the R star hash map, but with the extras hash map. Yeah, that should be good. There might be a better, clever way to do this without using so many data structures, but I think this should suffice. Int I is equal to 0. I'm just writing whatever comes to mind. I'm pretty sure that the syntax is all messed up. req si plus plus. This definitely won't work. So I gotta check if req has key. This is definitely wrong, but I'm just gonna write this as pseudocode, give it to ChatGPT to formalize it, just to make it syntax compatible, and then I'll submit it. s.i. If it has this, req si plus plus. Wait, it has to be T, not S. Else req dot put t dot I, comma 1. Wait, I gotta have 2 pointers now. Int L is equal to 0, R is equal to 0. While what? let's just start with while true, because I don't know what the exact condition is. I'll just write the code and have an if condition within which breaks out of the while loop whenever I feel like we know the condition. So to begin with, we gotta have a condition, right? We gotta have a condition. If satisfied, try to reduce, else then we just gotta expand towards the right. And our copy if r dot has key, then the character which I'm iterating over, which my right pointer is hovering over, is needed. So I'm just gonna wait. It's supposed to be r deep copy has key, r deep copy tr minus minus else if req has key tr. Okay, what this means is that this is an extra, right? Because my requirements are satisfied, you know, this has now become 0. Or you know what, instead of this, I think this is a bit shabby. Okay, what I can do instead is I don't need this extra. I don't need that. Yeah. I can just let it go to the negative. Yeah, let this go to -1. That just tells me that there is one extra of what I need. And this condition, I guess it won't work anymore because I'm not removing elements from our deep copy. I'm just letting it go negative. Okay, plus this has got to be an unordered hash map, not an unordered set. Or I think it's called, okay, whatever, since I'm not focusing on the syntax. I think it's unordered map, that is the right syntax, but I'm just gonna call it hash map. End map, let's just call it M for v is less than 0, greater than 0, so all of them are satisfied if this condition hits. This should be while r is less than t dot length. If r deep copy dot has key t of L if r deep copy t of L is less than 0, strictly less than 0, then L plus plus, and I gotta increment that because there is one less extra now. If not, if this has gotta be in another while true loop. Else just break, right? Otherwise, if the character at L is not part of what is needed, then just, yeah, again just L plus plus. Record answer. Int min answer size, int max. If r minus L plus 1, if it's greater than
If it's less, then min answer size int final L final R. L is equal to L, final R is equal to R. And then set both L to be equal to R. No, you gotta increment R, and you gotta set L to be equal to R. Return t dot substring final L final R. I'm giving you a snippet of C++ code. This is supposed to be a solution to a leetcode question. Now, this is very strict, by the way. I really don't want you to add or remove or correct anything in this snippet of code. What I just want you to do is ensure that it will work with C++. What I've given you is kind of like pseudocode, because I don't really have much familiarity with the syntax of C++, so it might be really wrong at places, but I think as pseudocode it does make sense. So I just want you to strictly adhere to the pseudocode which I've given, but just convert it into C++. Okay. How's the output? Just A. Cool. Okay, I think this should be our deep copy. I think I should probably make the font a bit bigger. Also, I think I should reinstate our deep copy to be equal to REQ at the end of this, right? Deep copy is equal to R, like the way it was initially, or REQ.
if min answer size int max, which means that you never found the answer, so you gotta return just an empty string. Find tr. So this is gonna hit, right? Cout found match. I think there is a way to debug through leetcode, but that is something which they gatekeep behind a subscription. So found match, okay, I see it happening thrice. tr found match ABC. Okay. Okay, wait. I think I made a big mistake. This should have been S all along. Yeah, this is a big mistake. S, 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 S. S all the way. Found match A. You increment R. ADO. At which point we just exit out. Okay, wait. The while condition is fucked up. So ADOB, and then I'm in all satisfied. You gotta update min answer size to r minus l plus 1. And this should be S substring. Found match BAC, but yet this didn't trigger. I think this is because the deep copy stuff isn't like working properly. Let's just have this over here. I know this might be dirty maybe, but it's good. Let's see what's happening at the end. I know what's happening.
when right is all the way at the end, you don't uh, you don't go to this part of the loop. Okay, I think what you should do instead is let this be over here, right? And let this be an if condition after the fact, after this runs. Cool. There is still something in standard out. I don't want to have that because it slows things down like dramatically. But where is the C out? Okay, it's over here. Wrong answer. A B B D A. Okay, so for this to work, I shouldn't do a R++ at the end, but still unable to make it work even with this. So when BDA satisfies for the characters in T, my R is going to be at 2 and L is going to be at 0. This condition is going to trigger. I'll notice that it is no longer feasible to reduce this any further, and this is going to trigger. R is going to stay as it is, and L is also going to become 2. So L equal to R equal to 2. Okay, but I won't. Okay, I know what happened. I just need to have this condition over here. No, not over here. Over here, I guess, yeah. Wait, still? Oh, so L equal to R at this point. So L equal to R equal to 2. I make a copy, I reset rdeep copy to the original request, and I find S of R, which is A, which is present, and I decrement it. And what is the value of L and what is the value of R? It's 3, 3. God damn. But why though? Why is it 3, 3? It should be 2, 2, right? Should I have this at the end? Yeah, I think that should solve it. So it is here 2 2, and then you increment r to plus, so it becomes L equals 2 and R equals 3. In the next iteration, you notice that B exists in S of R, and you notice that it exists in R deep copy as well, and you reduce it, and then it goes to all satisfied. You find that it is not really reducible. That shouldn't really be a problem here first. Final L is equal to 2, final R is equal to 3, which is, okay, I think it should be plus 1 then. What's going on here? Bank, okay. Here first 0 5, then it becomes 5 5, so you're at again C. 5 10, so you're starting at 0 1 0 1 2 3 4 5 and till 10. But okay, so this reduction logic isn't working then. That's what it means. Because this should have been -1. Okay, CV. How is it 0? C5. Oh, okay, so when it says here 5 5 at line number 65, it should also reduce the S of 5 by 1, so it becomes 0, and then when we are at the last character, then over top R should have been 10, right, and it should have been reduced to -1, so why hasn't that happened? It doesn't make no sense. here 5 5, reducing c by 1 0, reducing c by 1 0 again. What the hell? I hate this, man. I know the solution is right, but it's just we're just getting tripped up in the writing code aspect of this. Reducing oh god, this is just impossible to read. Here 0 5, where's that? Here's 0, okay, here 5 5. Reducing c by 1, it becomes 0. Reducing b by 1, 0. Reducing what, man? I don't understand. My logs are terrible. Absolutely terrible. Okay, let's just. And then you go all the way to b, reducing b by 1, which is over here, right? You're reducing. I'm just gonna add x here. Reducing c by 1, okay, reducing x b by 1, so your r is over here, and then for a, oh no, I get it. So at this point, this is valid. Code back. That is a valid answer. So you're trying to evaluate that and you move. Okay, so then your approach is like dog shit. It doesn't work. Or does it? Is there a smarter two-pointer approach which I've missed? Topics, hash table, sliding window. I think yeah, there is a smarter two-pointer sliding window approach, I guess, which I just missed. I think when
you have a solution, you should just move left by one to the right. So, let's say this is a valid solution, and it is irreducible. So what I'm going to do is I'm going to make this my next state, and then I'll try to find the next A. So that's going to lead me over here, something like this. Now I'll try to reduce, and I'll be at something like B to this, yeah. Then I'll do the same. I'll just move left one to the right, and this is gonna be my next state. Again, I guess. Wait. This was my. Wait. Let me zoom in. So this is my initial state, where I find my answer and I deduce that this is irreducible. So I'm gonna make the next state be equal to this, and I'll try to move right as much to the right as possible till all of my needs are satisfied. So it's gonna go till here. Yeah, then I'll try to reduce this. So I'll have something like this. This, yep. And then for the next state, it's gonna be code. So I'm just gonna get rid of C, and I'll try to extend this to the right as much as possible, and then I'll eventually end up with bank as the answer. I guess that is how you solve this. Cool, I'm just gonna stop here. I just don't think that this is probably the right time, or maybe I'm not really in the mood for this. So I think probably what I just said is the answer, but the implementation, I guess we can just keep aside for another session, or maybe I'll do it offline and let you guys know. Cool.